Chapter 19, question number 13. An atom in a crystal vibrates with SHM with a frequency of 10 to the power 14 Hz. The amplitude of its motion is 2 into 10 to the power minus 12 meters. Sketch a graph to show how the displacement of the atom varies during one cycle. So with the information that they have given, we need to figure out, how much it, we have to figure out how to represent this details. So this is a displacement time graph. So let's draw it. So this is the y-axis or the displacement, right? Because they are given in 10 to the power minus 12 meter units, I will write 10 to the power minus 12 units is used for each one. And this is the x-axis, which is t. T has been given in very small values with a frequency of 10 to the power 14 Hertz. So that means frequency of 10 to the power 14 Hertz. So that means it is 1 into 10 to the power 14 Hertz. T is given in, so I will write it as 10 to the power 14, right? So that is the basic unit, right? Then 1 into 10 to the power 14, okay? So that means this would be the graph SHM. This would be 1 into 10 to the power 14 point. So that is the time 1 second. This is the 1 second point. And 1 into 10 to the power 14 times it has vibrated. I hope it makes sense. So at this, then halfway point is 0.5. So this atom vibrates 1 into 10 to the power 14 times in 1 second. So these are the details. Then to fill up the left hand side, it is 0. 10 to the power 2 into 10 to the power minus 12. So you take this point as 2. This is 1. Then this is minus 1. This is minus 2. Okay. So these are the connecting points. Right? They should be quite. This 2 should be in parallel with the highest point here, and this negative 2 should be parallel with the lowest point. I know it is a little bit messy, but if you have followed the steps individually, you would have understood. If you have any doubts, please raise questions, then I will explain it further. Use your graph to estimate the maximum velocity of the atom. So obviously maximum velocity is at the, when you get the graph like this, you get the graph like this. Where do you have the maximum velocity? At this central point. So you draw the tangent and then find the gradient at the steepest point, and it would give you, if you have done it right, you would get about somewhere around 1.3 into 10 to the power 3 meters per second would be the answer. I'm pretty sure you must have got it. If you have any doubts, please raise questions.